Hi, Maggie. So, we're going to talk about geometric sequences today. And the way I was taught it was like this. Imagine a pond, and there are lily pads on the pond, and the frog wants to be able to get to every lily pad. The only thing that the frog needs to know is where do I start and how do I get to the next lily pad? And so, in terms of geometric sequences, this is your start conditions, your initial term. Where did you start? And this is the rule that gets you to the next lily pad. So I might choose to start here, and I have a rule that gets me to each lily pad. How do I get to the next one? If I know how to get to the next one, I can get to the next one, and to the next one, and to the next one. So that's all I need for a geometric sequence. My start term and my rule. So you might have, for instance, you might start with 3 and your rule might be to multiply by 5. So you know that the next lily pad would be 15. And then if I was to find the next lily pad would be another multiply by 5 and I would get 75. And I could keep going and go to the next lily pad and the next lily pad and the next lily pad. Yeah? So I need to know where to start and how to get to the next lily pad. That's all I need. Sometimes it might be if I started with 3 and maybe my rule was, and I'm going to write it over here, divide by 2, but it's the same as multiply by a half. Okay? And we always write them as a multiply because then when it's a multiply, I can write it as a power later on. So this time my rule might be times by a half. Times by a half. I'm just going to fill this in while I've got the same colour. So here are my lily pads, my terms, if you like, in the sequence. And this time I've got 3 lots of a half is 3 halves, or I could say 1.5. This would be 3/4. This would be 3/8. Yeah. And so on and so on. So my sequence is 3, 3/2, 3/4, and 3/8, dot, dot, dot. Yeah. This other one was 3, 15, 75. So when you've got a sequence that says I've got $1, so you started with $1 and you doubled it each day. Right? So you would start with 1, right? And the next term, right? Each day I'm going to double. So to get to the next term, so I'm going to call this T0, T1, T2, T3, T4. So that on the 4th day, my value will be 1 times 2 is 2, 2 2s are 4, 4 2s are 8. After 4 days, it will be $16. Yeah. Likewise, if you've got that cell that divides every hour into 2 pieces, I start with 1 cell. So you can either think of it as a multiply by a half, because each one is dividing into 2 cells, or you could say it's a doubling. Depends on which way you want to look at it. Right, so let's go after 4 hours on this one. Right, so this would be a half, quarter, an eighth, 16th. So that tells you that the 1 cell is now in 16 I have now 16 cells, 16 new cells, because each one has doubled. Yeah, or you could think of it as 2, 4, 8, 16. I'm not sure which way you want to look at it. The other one you had was a tree produces 2 seeds in its first year. So, the starting conditions are actually 2 seeds in the first year, and each seed doubles. So again, I've got a double, a double, double. So you can see where I end up depends on my starting conditions and my rule. So here I've got 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 times 2 is 32. But the important part, yeah, so if I labelled it T1, T2, T3, T4, T5, you can see that this is 2 to the power of 5. Yeah, it's because I've multiplied by 2 every time. Actually, that's, oh, I'm going to rewrite that. Hang on, let me start that again. I'm going to say I've got 2 and I multiply it by 2 to the 4. Because this is the initial conditions, and then this is your common ratio. So it's AR, and you may have come across that as well. Yeah, that might be a little bit further than what you need to go. So I'm going to leave it there. And if you've got any other questions, just let me know. Okay, thanks for watching. Bye-bye.